we are continuing with the Wikifycation of our ELTeC ELTeC collection. Now, colleague from Croatia, Benedikt Perak, will take the floor and present you some possibilities for data analysis, representation of geo-entities, interlinking, etc. Please, Benedikt, take over.
Okay, thank you. It's a pleasure to be here, and I hope you're still around. It's kind of late, so I think this will be one of the simpler versions of the hands-on. So, but it really is essential that you actually get the link to this presentation. So I would like you to have it on your screen, not just as looking at my sharing screen, but if you can access that on your, I don't know, half of the screen or whatever. So in this presentation, you have the agenda, which is less important. We will, go as we go. But the main idea is to create a Python-based pipeline for ELTeC extraction. We have multilingual parsing of text using two standard libraries, that is BASI and ClassLa, which we will skip, I guess, before because of the time. But ClassLa is here also. Information enrichment for named entity text structures. That means named entity analysis of language-specific corpora, implementation of automated named entity geolocation using neonative, and visualization using volume, as well as extraction of information with Wikipedia. And lastly, we would like to see how we can extract some contextual queries. Maybe we'll get there. So that's the hard part. Yes.
Sorry, where's the link?
The link. Where's the link? The link is in the chat. The link is in the chat. Maybe...
I will put also in a in a shared.
So Ranka Stankovic.
I will send.
The chat is not seeable in the, so I'll guess I'll share it again once more. Yeah. So when you get there,
I sent the email as well.
Yeah. If you have any problem, yeah. Okay. Diana got it. I guess. Whoever is here got it. If not, you can check your email. Ranka sent it to you. Mm-hmm. Yeah, this is the agenda. So you have this some kind of schematic thing, what we are trying to do, as well as the resources, which is more important, so to speak, now. You have this presentation in the first link. You have this Google Colab. If you click once on this version of, you can click here, and then it will lead you to distant reading Colab. And the third resource is actually OneDrive folder, where some of these more elaborated scripts, Python scripts are. So mostly the things are located in this distance BASI import py, and they contain the code that extracts lots of things that we're going to see in the column. You can also check some of the parsed data that are created using this scripts in ELTeC Data. So you have for each language, not every language, but for the languages I was able to parse in the preparation for this workshop, such structures like chapters, doc entities, doc token tags, doc or Deutsch header, etc., English, etc. So we can actually proceed to the Colab. I would like you to open the Colab, and when you open the Colab, you have to again log in with your Google account. I hope everyone has nowadays Google account. It's free, but it's not. Yeah. So when you create that, please just follow the steps here. Save a copy in Drive. That means you go to File, you save a copy in Drive, and this will actually lead you to opening a new copy that you can edit in terms of the title. You can say a nice copy of that, or my copy, or whatever. And this is where you can do whatever you want with the file. So because it's located within your Google account, and you can access that thing whenever you like inside your Drive, and it will be located inside the Colab folder. So it's somewhere here. Yeah, it's yellow folder within all these folders in the. So it's actually attainable after this presentation. So why I would like you to access and do some magic on this Colab is because I would like you to actually have interaction with the code. So yeah, this we did, and to have an interaction with the code, you need to actually activate the code. So this is on servers, and this will not take any of your memory within your computer. You just say runtime and run all. Yeah, this will maybe stop somewhere because possibly there are some errors, but if there are no errors, the code runs from the upper section to the lower section of the file. And in the left section, if you don't have it open, you can open the table of content like this inside the Colab, like that. Here, open and close, and open and like that. You have everything written here in terms of what we are going to go hopefully today. So first, there are some introduction, like previous workshops were dealing also with NLP tools, Spacey, Geo-Data, but this one is specifically extracting data from the ELTeC collection. So yeah, this was agenda. We went through that. These are the intro slides. These are the some other ideas. You can see the shared folder also here. Yeah, it's doing some stuff, and yeah. Excuse me.
You must see that we must on our file, on our drive.
Yeah, there's some error. I don't know what.
Yes, so. Well, first you must download. The model is not. Download here.
Yeah, if you have any problem, I suggest you should actually say restart and run all. That will take care of some errors that are not due to syntax errors, or there are some kind of systemic errors. So let's run the code, like runtime. And restart and run all if you have any problem. And let's see what we have. So first up, we have some installations. So Python basically a tool that runs like an R, but one of the advantages that I see in Python is that you can build some kind of system out of all these modules, tools, and nowadays they're kind of advancing in sense of what we've seen in semantic domains, these deep learning libraries, etc. And there are lots of stuff that you can build really out of the box and connect all these things into some kind of meaningful system that could be eventually interrogated and used for data analysis or whatever. So that being said, the installation for any kind of library is very simple. You just say, you know, this exclamation mark pip, and then install whatever the necessary library is, and then we can proceed. Here are some important libraries that we'll use for this session. So if you have this this green stuff here, that means it's okay. So we'll import text from ELTeC repository. You've seen how it looks like. So we have a list of languages that are inside this repository, and basically you can see that many of these languages we've dealt with, and if you are one of these languages that we didn't deal today, I guess you try this this Colab now. So for instance, you know, I know that there are guys from Lithuania here. You could actually say here language equals, and then use this lit here. Try this out, and lit, and activate this cell here, run cell. So previously we saw it was actually activated for Portuguese. You will not perhaps activate the cell now because it's running. I guess it's parsing the data that we actually, you know, told him runtime run all data, but using Portuguese. So leave this for now unchecked or not cleared. So I guess we'll go and just try to catch the sense of what we're doing, and then later on we can, you know, change the parameters. Yeah, so here we have this function that actually imports the text from ELTeC repository. The function is defined as def, and then we have some kind of name. You see it's kind of brownish, and you can actually call this function to do all this magic stuff inside the function. So it will, this function will return, I guess you can see, links. And we can use this function wherever we want. So I won't go into detail, but for some of you, maybe that could be helpful. Here we have some kind of, you know, you can actually, it's kind of convenient. You can choose whatever ELTeC edition you would like. So basically you say, I want like Romanian, and I want level 1, and yeah, it should work whenever the thing stops. Yeah, that's the problem. That's there's always one procedural mistake that one. Can you see some other links?
I suppose it is downloading model, because you put a download all, and then
No, it's not downloading all. No.
Everything is okay.
Yeah. I can maybe stop this.
Yes, yes.
Yes,
I can.
I will stop interactive
Press
execution
Enter,
for,
yes.
well, so like this. If you run this cell, you will get for every selected language, for every selected level, what's inside. So you can click on any of these links and you will get this raw data, which is actually this file that we coded in XML. So that's one neat thing if you want to see how this raw data looks like. And like I will switch to Lithuanian links, something like that. So you see we have these 12 books for Lithuanian. And next up, we have get XML books from these links. We are just having links, we are not having the data. So this function, if we activate this function, it will actually return the books. And out here with this books equal get book links 06, I'm determining that I want just 5 of those books because some of you were very eager and you had all 100 books. And no, we should actually in this collab run only a small example. So 5 books should be enough to see the essence of that thing. So if I say get books and yeah, error, some error. I guess we'll not do the Lithuanian now.
No, they don't have
Access. What's
no, maybe.
Да, so we'll switch back to
Yes,
Portuguese. Yeah. Okay. And later on, I'll try to see what's happening.
Yes, for Portuguese it works.
Yeah, you can get the books. Yeah, so I would like you to maybe check and see if you get an error. Perhaps you can say, hey, it's an error and we can sort it out. So let's just dwell for a second what type of data that is. It's a kind of order dictionary. And of course, you can just skip and see that it has the day structure. And of course, we need the 2 things that are most important. The header, which will give us something called, the metadata. So you see here all the metadata structure for these Portuguese books that we said we want to collect. So for the first book, you can see how this looks like. So all these metadata is extracted by using this function. So the header contains all these structures that we can use later on. For instance, we can check who's the author, what's the title, etc. But let's move on further to chapters. The next activation will get you all the chapters that is actually within the P section of the XML tagging, and we are creating from this P some cell that's called text. Yeah, later on we are actually trying to do some kind of text analysis. I hope this was clear enough, and you can use this portion of the data to search for the collection of the books that is not using ClassLa. So you've seen in the beginning, there were some languages like Croatian, Serbian, Slovenian. These are not included in the Spatie library. So only those that are actually in the Spatie library can be parsed. So this is the next section that we are going to do. So we will process this head and peak columns from chapters data frame. So we got these chapters and you see how this looks like. If you don't replace all these T's and nuns, there are some strange characters running around and we don't want that. So I'm not going to go into NLP as such, but let's just remember that parsing language, or this kind of magic that happens within the natural language processing, is just part of segmentation of tasks. So many tasks that add to the complexity of the analysis. And if you don't have like, let's say segmentation of sentence, you cannot go to next level. Or if you don't have tokenization, you cannot have the part of speech, you cannot get the lemmatization, etc., etc. And the named entities are very high up in terms of complexity, not just what we heard today from Diana, this conceptual complexity, but also for extracting what is an entity and can be not trivial, even for just segmentation of what it is. Not to say the categorization of different types of entities and subcategorization, etc., etc. So all these NLP tasks, you can see them here. I will not go into details, but there are some nice state-of-the-art dimensions that you can check out later on. So for now, we will use the Spatie. I guess you've all seen Spatie. You can check the usage here, how to install, how to import, how to load model. This is what we're going to do now. So first up, you install the latest upgraded version of the Spatie. If you want to use larger models, that's very important. And then you have all this importing, blah, blah. And here we come to the example, how to activate a model. We're first downloading the model, and then we are activating with these functions. So this NLP actually stores all the pipeline that we saw earlier. So it contains tokenization, lemmatization, blah, 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 for English, and this is the version of the model that we're using. So example, text, and then you actually apply this NLP pipeline and you get a doc model, which is a very important data structure that contains many substructures. One of these structures is entities. So you can access the entities of text. This line is saying for each entity within this document structure, get me entity text and where it starts, character, and get me the label. So this text and label are very important for us. So you see that it's going through the text. Apple is looking at buying UK startup, blah, blah, blah. And it's getting Apple as an organization, UK as a geopolitical entity, and it's getting 1 billion like money. That's a large number. Okay, and then create an NLP parse token features of a doc object. Here is one dictionary of all inside. This was only entities, but you can access any token and you can see what it has inside the Spatie. So, for ones that didn't see that, that's kind of interesting. For others, not so much. Of course, you can use also libraries such as Displacy to render the what is actually missing from the ELTeC edition, even the second edition, the dependencies between different tokens. I think this is quite important in terms of analysis of any kind of statement, linguistic statement. You have to know what's the subject, what's the object. You cannot have a meaningful conversation with anyone if you don't have the structure of the lemmas within this thing. So I guess many of the queries that we're going to build upon are basically the function of these dependency structures that we are seeing here presented as a model. So again, there are different kinds of presentation modules, display, etc. So this is the processing pipeline, which is pretty similar to what we've seen. And now we're coming to lots of text. And here we have the load section for different languages. So I've tried to cover most of the languages with this core small language models. So you can choose here, you have to activate this load model. And if you want to change from Portuguese to some other edition, I think we will not do that immediately, but you can choose for Romanian, for instance, or you can choose for English or French, etc. And you will get first the download of the model, and then it will activate like this. So next up, we have the pandas. The pandas are for our convenience. So this is a tool that actually enables you to work with data in a more human fashion, so to speak. And we like these tables a lot. They are very intuitive. We don't like these dictionaries that we've seen before. So everything is represented here as a data frame. So if you want to actually see what's inside, you have to kind of convert this document that we had earlier, like this doc that had Apple is looking blah blah blah, and you say, please Panda, convert this dictionary into data frame. And
sorry, Diana is asking, is this level 1? If I not
yes.
use the model for Portuguese, okay, now you are back to English.
So, no, this is just an example. This is just an example. Inside this doc.dic, we stored this example. Apple is looking at buying UK. It's just an example. Thank you for the question. Yeah, and I'm just presenting how you can convert this dictionary format into tables format. Okay, so next up we have processing the text from chapters into Spacie document object and retrieving it as pandas document tags data frame. So this token tags will contain every word tokenized with all these features for the first chapter of the Portuguese level 1. Okay, so when we actually activated this, I've seen that it's activated. I will not activate it again, yeah, because it will take time to process it. You can see that we have for these 5 books something like almost like 1 million tokens.
Hey.
So,
Like, yeah.
yes, it's 800,000 tokens for 5 books. So, and you see all these additional things within the columns. So you have the token, you have the lemma version of this token, you have the part of speech, whether it has some conjuncts or not, what's the tag, what's the dependency, and what's the head of this dependency, because it always has 2 things that are dependent. One on another. So now, of course, there's something called vectors. Like these vectors are normalized. these are not vectors in like deep learning when you have like hundreds or more columns of numbers that represent the specific position in this multidimensional space, but this is normalized vector for each word, and it's kind of fun to do when we already have it, some kind of lookup for the normalized vector similar words. So this is one exploration of what it can do. I'm curious whether Diana will find it meaningful. Yes, please. There's a question here.
Sense they are normalized. Is it like even vectors or something like something other?
We have to check the specific documentation on the spacey, but I suppose because it's one number, that means they're kind of compressed into the vocabulary type of number that represents their position. So it's in no sense like this multidimensional vector that we would like to have that represents the semantic meaning of the word. But yeah, so what I've done is when you take the lemma, it's going through the whole section of 800 tokens, and it's trying to first find the lemma, and then it's actually looking at what's the lemma of this word or words, and then it finds the words that are within this vector number similar within this distance. So you can actually change the word. For instance, if I say tempo, let's say tempo, here you can change, if you know Portuguese, and you can change to not 7 but 15, or 17, and then activate this cell by using this run cell or control enter procedure, and it will get you some other words that are of the same part of speech. Yeah. Diana, is she here?
Yes, I'm sorry to say that this is mostly rubbish.
Yes. No, I expected it so. Yeah.
Probably because it's the small model, or
no, it's actually small for in terms of the finding words. Maybe it's also a small portion of the tokens there. So that could be it. And of course, we are seeing only one dimension of something that's like 300 dimensions. That's kind of what you would expect. But yeah, so this is to disillusion us, perhaps also good, you know, not to be so dependent on numbers only. But you can do some of the things. Maybe if we could search for every vector of these neighbors, then we would actually get some graph that would connect similar stuff. Perhaps you can create some query of that. Next up, we have the map title of, so we want to map title and author metadata to data frame, because we extracted only the text portion and we don't have the author, or we don't have the title, but we have this XML ID, and you can actually then just assign on the column here for each row these things. So that allows us to check whether portion of the text is represented in this book or that book. So next up, we have this assigning row entity to capture multiple token entities, but this is very slow, and it took me ages to run through it. That would enable us to capture, sometimes named entities are not tokens, but multiple tokens, and that would enable us to have the multiple tokens on this data set, doc tokens tags. So what we do is we create get doc entity tags, like we saw here, but this one I interrupted. I will switch to my here. I have it here also. Okay. Yeah. So when you process this line, get doc entity tags, you get only entities that are within spacey represented as multi words or single words. Of course, there are some miscategorized things, but you have to deal with it, of course. And what we see from this portion of 800 tokens, we got something of 31 token of named entities. And here is some kind of descriptive statistic on named entities that gives us how much person, miscellaneous or organization. We have locations also, and yeah, different representation of the same thing. And we see that mostly these are persons and organizations. I'm sorry that we don't have much locations here, but we can check for that later. This drop-down menu enables us to go through various types of otherwise, tagged locations or named entities, sorry, and you can extract them here. So as location, there are only 3,000 occurrences of locations. And here are the data frame that captures these locations. So what we want to do next is selecting part of the lemmas that contain this specific locations. For instance, if you check, let's say, Lisboa, I will get, instances or tokens, and I can then have all these various information about where this occurred, in which book it occurred, etc. And we'll use it later on. So we want to actually see more of the context, of course, and here you can define this keyword in context, some kind of small application. It doesn't look fancy, but if you're interested in text, I suggest you put here some kind of search lemma and 50. That means from the left side, you will see 50 characters, and on the right, you will see 50 characters more. So if I say like only 10, I get only 10 characters left and right. I guess, okay, what's the... Yeah. This can be important if you really want to access some context, not using these digital tools. Next up, I would say we need to geomap this this thing. I have also some kind of reminder that we can import these entities from Google Sheet. Ranka gave me one, but I don't think we'll do that now. So we'll do that maybe later if you want. But let's go to this geo mapping data. As soon as we have these location as names, we can then search for the geolocation. That means latitude, longitude. And for our convenience, there is something called GeoPy and Nominatim. These guys extract the exact location, or they try to extract the location. And you can see here that I've asked, please give me entities that are either geopolitical entities or locations. Portuguese doesn't have GPA tagged. I'm not sure why, but this is the thing. And here we are calling the nominating tool, entering the location name. So you can actually change the name here to, let's say, Lisboa. And this will give you the numbers, the latitude, the longitude. Of course, if you want to see the data frame, this is the whole section that will give you the data frame called locations, data frames. So these are all the entities that were extracted. So why not 3,000? Because most of these guys are repeating itself. So we are only searching for the unique names, which are actually scarce here. Yeah, and these are the locations. So now we are trying to map the latitude, longitude on the entities. And this is how this data frame looks like. Again, we are having much more entities here. And you can do in reverse. So you can extract from a location some kind of name, and then it will give you this location is somewhere near Belgrade. And yeah, you can see how it goes. The Wikipedia module gives us opportunity to have some of the features of geo positioning, and I guess that would be interesting if you want to actually see what sections are close to some geopolitical entity or location. For instance, Lisboa has these entities written inside the Wikipedia as pages. So this part of the code actually says, go and look in the English Wikipedia, and for each entity, give me 5 results within the radius of this much meters. So you can change that. Perhaps that could be useful for looking whether you could add some wiki page entry, or whether something important was on that site for the specific book, for the specific place inside the novel. Next up, we have this representation of mentioned entities on the volume map. Documentation is here. You can again install the volume like that, import volume, and entities with longitude, latitude, because we got the locations, but some of these were not included inside the neonatim. So we are just trying to map the ones that have all, entities with longitude and latitude. And this is how it looks like. So for entity, we are looking at Bayacunas, Jado, and these are represented in these books so many times. So this basically similar to what Diana has shown us. You can process the whole corpus and you will get some data analysis like that.
Sorry, Diana asking, the names of the locations are in which language? Should be Lisbon or Lisboa?
Yeah, I guess it's giving you the native locations. So again, for Serbian, it's getting us the Cyrillic, and for Lisboa is Lisboa. But it will actually look for the various types of representation of the same entity. You can write Lisbon, Lisboa. Yeah, so basically, but it will get you back the native representation. Yes.
Sorry, if I can add, I haven't worked with this, but the other library that works with Wikipedia, they by default they work with English Wikipedia, and you can set language. And then when you set language, then it looks to other Wikipedia, because you know that Wikidata, it is one knowledge base. It's one URL, but each Wikipedia for each language, it's completely different resource, different URL. So in Wikipedia packages, then you have to definitely say in which language you search by default, and then it depends on library to library. If it is not found in the specified library, it looks in English. It's most frequent option.
Yeah. So English is our default option if we fail. Okay, so the search lemma chart is basically what we've seen, the concordance. But out here, I'm trying to also encode some of the HTML stuff that I will use in the representation of the map. So it kind of looks silly here to have all these br and b and I don't know whatever, but you will see here when we actually represent this thing on a map. So all these mentioned named entities are here, and you can see within this small section that you can see the context where it was mentioned and which book it was mentioned. I think it's kind of cool, needs to well, and by checking this these markers, you can see that some of them are, not quite, not in this section perhaps, but Ora, I'm not sure it's a kind of location at all, but, in some instances it could be, but in some it's definitely some, part of speech or some particular whatever. So I guess this can be reused, and you can create a whole bunch of location markers with the text portion that represents the instance where this location was mentioned in the text. So one, I would say, funny option is when you have the locations and when you have the novels, you can check how distant was conceptual writing. So for each novel, we can calculate how distant were all these places one from each other. So this script is calculating each location and measuring distance each to each. And I would say that this Viagens would have to have the largest number of the kilometers. So, and it really does. That's a cool option. So, I guess we can see whether there is some kind of significance to that. But next up, we have this Wikidata, and I guess we have two more chapters to go, and this one is actually familiar from the last speech. So we have Wikidata, and all cool stuffs are happening inside the Wikidata Foundation, Wikidata base, and soon we will have all the ELTeC metadata inside the Wikidata. So it's only reasonable to have this kind of connection to this systematic data consuming tool, and you can use it like that. First, you have this function, like activate the function, and here this Wikidata items def, you can ask whatever you would, for some entity. So let's ask for Lisboa. And we see here inside the table all what can be Lisboa. So it's a capital city in Portugal, district in Portugal. It's a family name, live album of Mother Deus, Mars Creator also, and something called Nan. That's kind of important, and it goes to Diana's actually argument. It's very hard to see the different types of categories. Of course, if you say Minho, like Minho, I guess that's also some kind of location here. You will see that the Minho is also former Portuguese province, but also South Korean rapper. Sometimes these things are totally world apart, but sometimes they are not. Okay, so this is one cool feature, also because you don't have to search for these cues online, like that was always hard for me. Like, how can I find this cue? What's the idea of like water? I don't know. So with this cool section, you can just here say water, and you will get the ID of the water. Of course, check whether this is not some kind of album of some rock player. Yeah, so we can get the Wikidata for identified location mentioned in book like this. So for each entity that we saw inside our entities with longitude, latitude, we drop duplicates and we go through every entity and we look for whatever was there. And even we had some sparse section, you get the whole bunch of things inside, like how many? You get 2,700 entries out of like 13, 15 locations. So you can see the complexity is building very fast, and we need to disambiguate somehow. And if we are going to include this Wikidata, to have some kind of filters that could actually enable us to use this the very important database for a benefit. So I'm actually not quite there yet, but let's say this is a very cool beginning of the integration of Wikidata into our endeavors. Of course, there is something called a claim that actually spits out the connections of a specific entity to all other things around. So properties and entities, and this could be explored in terms of creating large graphs of connected things for each entity. I think this is very cool stuff and needs some more exploration. Further, we have the Sparkle query Wikidata that we saw earlier, and you have to install this Q Wikidata, which stands for Query Wikidata, and this gives you, first, again, something very similar to what we've seen for a entity, unique entity. We get all these things, but here is this Sparkle example, which is basically the first example in the Wiki Sparkle section. So give me all the cats. So how it's actually written, it's you select an item and item label. These are like variables where an item is some kind of property. Property here means instance of, that we saw earlier, instance of human or cat. Like this is a cat, instance of cat. And querying this Wikibase label, you can get all these cats that are on the Wikidata. So this can be just an example how this thing works. And from this example, I've created a function called people born in location. So that is something that we can explore right now. So I would like you to get people that are born in Lisbon. Can you give me the first two? Like humans that are born.
Milica not counting.
Hmm?
Milica is not allowed to answer the question.
No, but you have the answer inside the previous section. So first you need to find what is the queue. And you have to go up there, but this is also cool. And search here, Wikidata items data frame. First here you have to search for Lisboa. Then you
Or go to Wikidata.
yeah. But we need to kind of see how the progression inside the programming works.
Sorry.
So how to connect various data frames and stuff like that. Yeah.
Really joking.
Lisbon is 597.
Okay, that's 5 names.
To have location that we unexpected.
Yeah.
We data from that class.
Yeah, so we get 597, Q597, and then we come to this query, who is born in the Lisbon? It's almost like a song, but not. So where to put this query? Here, people born in location. So now I forgot 597, huh? Is it?
One tip, what I usually do to help myself, because it's very easy to make a mistake when writing a Sparkle query. I do it in Wiki service, Wiki Sparkle service, because it has IntelliSense. And when I'm sure there, then I just copy and paste in in the code or somewhere.
Yeah, Diana is saying Europe points to Germany in the map and with a smile. Well, I guess there is this middle place somewhere, Erdingen or something like that. Okay, yeah. another. So now we have all these Antonio Guterres, Luis de Camara, Persosa, Luis Figo, yeah, that one, you know. And we would like actually to filter some, you know, query. And here we have another function that enables us to query people born in location in some specific time. So this function takes Q argument, Q location, and parameter year, like from and to. If we want to see the people born in Portugal in 1850 to 18 or 2000 or 1900, let's say. So we say Q597. And then change this to 1900. And we would get all these data. So you can imagine that we could use these two functions to iterate through every location that we got for the book and get huge amount of data that could or not be related to the content of the book. For instance, we would, for some books, want to know who lived or who was born in London in times of the, some kind of period that is expressed in the book, etc. So by using these queries, we can actually get the context of the book from the knowledge base. And of course, we're looking forward to some more queries that we will perhaps create with help of Milica and the great team here in Belgrade. Okay, so let's move to the last section. I hope this is. Do you have any question regarding this before we skip to something completely different, like Monty Python says? Do you have any questions that are related to these?
Online people do.
Excuse me?
We have a question. We're getting Serbian people when we add the QID for
Yeah, because excuse me.
Yeah, I don't know, what did I do wrong?
Okay. What is wrong? Yeah, you're right, because I did not code it well. So you have to well, it is a mistake here. Yeah, this is the mistake. This is nice, because you have to code for yourself now. Yeah. So we'll copy this section, Q location, copy it and put it here. So like that. So instead of Q3711, which is Belgrade number in Wikipedia, we will put here Q location. And one more thing, we will actually select the whole thing and then say Alt B. So we have to have these curly brackets. And for the other thing, again, select Q location, Alt GR, and then B. And one more thing we have to do is we have to create this part of this F string. So here before human, question mark, human, we will put 3 single quotes and then say plus, again, 3 single quotes, Oh, no, not single, sorry, double quotes. 1, 2, 3. Plus here, and after plus F. So yeah, this is how it should look like. So after this,
Do you need one more plus?
no.
Okay.
Yeah. So because we are actually passing this variable Q location as a variable inside this query, and it's possible only if we say give me this string as a F string that allows us to neatly pass the variable here. Okay, and now if you activate the stuff, okay, so human the check. What did I wrong?
Isidoro, is this a question from before or you have a new question?
No, it's the same one, sorry.
Okay.
Maybe I'll have to check what's wrong with them.
Maybe you can go
Da.
and then you will receive the adapted file
Yes.
tomorrow, and I think
You
that
can check
now,
later on
yeah,
the real file. I don't know what's
we
creating
can
this mess.
continue with the next section.
So the last section is creating knowledge graph from co-current named entities. So this was introduced in the previous workshop that we wanted to see what entities are collocated. So we search for one entity and we get inside some kind of distance other entities, and then we create collocation between those two. So let's say we are looking for Minho and we are looking 100 characters left and right, and we get all these entities that could be location or person, etc. And yes, this enables us to get collocations. That means that we can pass many of entities inside this get collocations. So I can say Minho, Ega, and then I can ask for Lisbon, one more, Lisboa, and this will add from 66 to working to 86 entries. So each thing is some kind of yeah, we have to again do this here, sorry. We have to do this inside this call def Lisboa, because we need to have this call def data frame from where we can extract the collocates. So each collocate That means Minho and Deus, Minho and Proudhon, Minho and Paris are collocated and create this graph. You can see the graph here. These are all just preparation. I won't go into detail now, but you need to activate all these things to actually come to this section, which is called F graph draw plotly. That will draw this graph. So if you want to see what we've done from this collocation section, you say runtime and run after. So that will actually activate cell by cell, and this will pop up until the next. And this is creating graph, this is installing, this is creating this new graph. And finally, we have some kind of graph. This none can be also deleted afterwards, but we can see what entities are connected within the 100 characters. So maybe if you have the whole section of the books inside, we can see some kind of structures of connection between entities. And of course, you can also filter out only locations, only persons, or persons with locations, etc., and get this kind of graph experience. Yeah, so I will stop here because I think we've done lots of things. If you have any questions that you would like to ask, that's also my idea is actually to run the whole section of the ELTeC edition and present these things on the app that we can host maybe on some server, and you can then access the whole data section from this server. So with this in mind, if you're willing to help or willing to collaborate on this project, I think that will be a cool ending of the whole section.
Definitely. And but I would suggest, and I suppose Diana, to focus on level 2 that is already published. So do not go again through Spacie for those that already have named entities on GitHub. So for those languages that have level 2, make level 2 reading. So that's one path, and second path should be some kind of Spacie procedure, automatic procedure, or whatever stanza to retrieve for other languages. So
the problem I
don't know if people online can discuss, because now we are moving from training to some workshop.
For instance,
here,
like Portuguese for level 2, let's say I'm trying to access that thing. Okay, so what I see here is XML, and of course we have here displays and work, etc. But for many other languages, there isn't like, let's say, if I don't know what is the level.
French have still, but they will have.
They have some kind of level 2, but here, yeah, nothing of that tagging is here.
No, that's why I said.
Yeah.
For those that have, use what is inside,
Yes.
but for the others, some path with some kind of automatic procedure that you presented earlier can be used to have more data.
Yes, yes,
And
yes.
then-
Yeah. Yeah, I hope this whole procedure can be used by you, and you can, if you do something even better, I hope with this, you can just drop an email like, hi, this is what I've done. That would be really cool from my side. Thank you.
Thank you very much. It was very interesting, and this last part is super interesting, and something that will be, I think, the nice wrapping up of name entity recognition group. It will bring in one place all information. I would really, from my side, I would like to be part of that. Now I give a floor. We have some time for questions. As we discussed a bit earlier, we decided here internally to try to finish a bit earlier. And if some specific questions arise, we can exchange mails, because this was really a long day with lots of information. So now we can discuss. We have time for some discussion, but if you come up later with some questions, feel free to contact any of presenters today. I would like first to give a floor to online participants to ask questions or comment. Alexandra, thanks.
I don't think to. Thank you, Rich. I'm still working, I think.
Okay.
So everyone is thanking, but
okay, so
we are
all
thin, like
yes.
conceptually thin.
Yes, yes, yes. We will all have will require I definitely go slowly through the Benedikt's very rich notebook, and to see each part. But I think it gives us so many opportunities to see.
Tamara.
Tamara.
Yes, thanks again. I think I messed up something when I tried out step 1 of this, creating a knowledge graph from co-occurring named entities. I wonder if you could just show that again.
No problem. Wait, I have to.
I don't know what I did, but it's not working anymore.
Don't worry, you always have the original link.
Oh yeah, all right.
So
yeah,
can,
that's right.
yeah. So you can always go and just copy the whole thing again if you
yes, okay.
like, or part of that thing. So I don't know what you did. You know, it's not. But the whole procedure starts from I don't see here now. Blah blah blah. Get collocation. The whole thing, creating a knowledge graph.
Yeah, that's where I did something.
So first function just creates one collocation, and then the second get collocation is a list. So you have to put these these brackets, this not curly but uglate zagrade, square brackets,
That's correct.
So because it treats it as a list, so you can pass whatever, how many you would like, and it will create the graph from there. And also, this is just a function. It will be cool if you maybe, you know, pass it here, because this column def is the variable that stores the graph. This one is just for show, and maybe it's, you know, you better just delete it.
Okay.
Delete this
Okay.
one, and then you will actually be more safe.
Okay.
Because you have to then activate the next one.
Okay. Oh yeah, it seems to be working now. Great.
Yeah.
Okay. Yeah, thanks.
No problem. And thank you for your also question.
Benedikt, I wonder if I can just correct your Portuguese in one thing. Is it this?
No,
These were in,
I don't allow it.
or not yours, but everyone who heard this all the time. This province of Portugal in the north, it's pronounced Minho, Minho, not Minhu. That's
Yeah,
that's like Korean.
Just, I was speaking about this rapper, you know.
Just in case you present it somewhere else, then you know Minho.
No.
Okay, thank you all. Joanna, are you with us? Christoph, would you like to?
Yes, sorry, my internet connection is fairly poor, but I'm here. Yeah, and so.
So,
Yeah, but
yeah,
sorry, I mean.
okay, if you do you have something to add for us today? Because now we I think finished here what we wanted to do, and now we are going to Kafana, nearby Kafana. So we will continue there our very hard talk about these topics, and we will miss you. We will miss you definitely. So
Yeah, you all have a great time, and
okay.
for this afternoon session,
Yeah.
Ranka, Peter, and Benedikt. It was really interesting to listen. I'm very sorry that my Wi-Fi service got disconnected for some reason, and I'm struggling with my connection coming back and forth. But definitely what I heard was very interesting. So I hope everybody will have a lot of fun, and we'll see you tomorrow. I think there is nothing to be installed for tomorrow's session.
We sent, yes, there is. There is to install, but we sent information, and I call everyone to check 3.1 what is required for the session, and it will be also hands-on that requires very active role in the session.
Well, then make sure that everybody gets enough sleep and rest for tomorrow.